So in this lesson we'll have a look at cliff retreat, which is also known as cliff recession. This is where the face of the cliff moves back, and certainly we've seen this in the videos where we looked at Hastings in previous lessons. Do remember though that most students get things a little bit confused. They will just talk about the processes of erosion, but cliff retreat actually does also involve weathering and mass movement, and we'll look at that in a little bit more detail throughout this lesson. So have a watch of this video and you will see that first of all these are the four things that students would first of all talk about. They are the processes of erosion, hydraulic action, abrasion, attrition, and corrosion. Corrosion with an O. But do remember, when you watch the video, it's not just the processes of erosion that cause the cliffs to retreat. There are other things going on as well. Looking at another example from Sussex, Beachy Head, please go into Google Earth and find Beachy Head to see what's going on there. Again, watch this video and that shows some really good examples of cliff retreat to help you understand exactly what's going on. Okay, as we said earlier on a few minutes ago, cliff retreat or cliff recession, it occurs because there's a combination of weathering and erosion and mass movements. So first of all, we'll have a think about the easiest thing to understand. So you've got your wave attack zone. There is your wave attack zone, and at high tide the waves will smash into the bottom of the cliff and will erode it, and you will see it will make what we can see here as the wave cut notch. There is the wave cut notch. But there are other things going on as well. Eventually this section of the cliff will fall down, but while that is hanging there, it's also going to be weathered. So first of all, we need to have a think about what's going to be causing that weathering. Well, one of the weatherings is going to be biological weathering, and there you can see the trees, the little grass there in this diagram will help to break up the rock. We've also got salt crystal growth, because you'll get a spray of salt onto the rock, and that will also help to break open the rock as well. One thing that is not in this list, and we'll just add it there, of course, is freeze thaw weathering. We'll just add that to the list there, and that's where ice starts to form in the cracks, and as you know, ice expands and that will gradually crack open the rocks. So we're getting into a situation where we've got the cliff both being crunched up and broken and cracked into smaller pieces, and that's the weathering. And then at the bottom here with the wave cut notch, we've also got erosion. So it doesn't take much to work out that as this wave cut notch gets bigger and bigger and the cliff above it gets more and more cracked up, it is eventually going to fall down. And as we know, and as we've seen in the videos, this is known as mass movement. Mass movements are of two types, which we'll look at in a bit more detail: rockfall and slumping as well. This is quite a nice little computer animation that shows the cliff recession. We're going to have a think in the lesson about how to draw a step-by-step diagram in our examination to show what exactly cliff erosion is. If you don't like a step-by-step diagram, there are other ways you can draw this diagram, which we can discuss in class. Watch the video and that will give you some ideas. In front of the cliff here we can see that this is the original position of the cliff. That's the eroding cliff face, but in front of the cliff we're going to have something called a wave cut platform, and that's an area of flat rock that's directly in front of the cliff. In this picture we can see that it's actually low tide, but at high tide do remember that the way the water will completely cover the wave cut platform and actually come into contact with the base of the cliff. As well as that, the other thing that you will see from the diagram is a wave cut notch. This is Mrs. Bobson, actually Bob Bobson, wife. Those of you who did geography with me in year 8 will know about Bob Bobson. There's his wife, and his dear wife is standing in front of a wave cut notch. Okay, remember here we've also got the wave cut platform, and at high tide Mrs. Bobson would actually be standing in water and would be hit by the waves. Mrs. Bobson, at high tides during a storm, you really need to move. Okay, as we said before, we've got two main types of mass movement. Mass movement is where rock just falls down under the force of gravity. We've got a slump. There is a slump, you can see the whole lot just falls down. Actually, you've still got the section of rocks there. You can see the layers. The other one is Rockfall. That's where just pieces of rock fall down. And there you can see in this picture, you've got the rocks at the bottom of the cliff. Remember, these rocks will be removed, because you will notice if we look back here, this platform, wave cut platform by Mrs. Bobson, hasn't got lots of rocks on it. Those rocks have actually been moved by the processes of erosion and transportation working together. So the fallen rock and soil will be moved by longshore drift, of course, which we've looked at in previous lessons. One of the things that you'll know about, classic thing that all geographers love, is the formation of headlands and bays. Here you can see that we've got the waves coming in, attacking a section of coast. The green are areas of resistant or hard rock, which will erode slower, and then the brown colour is the less resistant rock, which will erode faster. So over a period of time, the different rates of erosion will give us the bays, which are the soft rock, and they will give us the headlands. Go and have a look and search for some pictures on Google Images for headlands and bays, and you can see this in a little bit more detail. Great video here about St Bride's Bay in Wales. Again, please go on to Google Earth and find St Bride's Bay. Watch the video, make some notes. That'll help you to understand what's going on. A cave, arch and stack. I would suggest that you go and find a diagram from the internet which shows a cave, an arch and a stack. This area here, there's the stack, there's the arch, and there's the cave. Originally this was a headland of resistant rock that stuck out into the sea, but over time it has been transformed into, first of all, a cave, then an arch, then a stack, and then here we've got a fallen down stack, which we know as a stump. We're going to talk a little bit about that in class. Here's the classic diagram, which is easier to understand. That's based on a place in France called Etretat, which I went to as a child with a school trip way back when I was a year 6 student. So we might like to go in, perhaps we can go into Google Earth during the lesson and look at Etretat, which is on the northern coast of France, which is the absolute classic cave, arch, stack and stump. Again, we'll have a think in class about using step-by-step diagrams or single diagrams to talk about the formation of a cave, an arch and a stack. But remember, the caves, arches and stacks form in areas of resistant rock, which form the headland. Eventually, of course, the headland will be eroded away and we will go back to a situation like here on the left-hand side, where we've got a almost flat area of coastline, and then the process will start over again. So in class we will have a look again for some more images. We will go into Google Earth and Google Maps to find some satellite images of this, and then we'll also talk about using diagrams in examinations and the importance of understanding the processes of weathering, erosion, transportation and mass movement when explaining the formation and development of these features over a period of time.